So your Kotlin project finally has nice, clean, coroutine-based code when suddenly you need to use a third-party library that only supports callbacks. Does this mean that part of your project will be able to use coroutines and part of it's just going to be stuck using callbacks forever? Well, thankfully, with a few small changes, you can adapt that callback code so that it works with coroutines. To show you what I mean, here are some callback-based interfaces that you might see in a third-party library. So for example, an auto shop might need the customer to approve an estimate before they get to work on their car. And they can just call this request approval function, and whenever the customer responds, it'll use this callback interface to inform the main project about the customer's decision, whether it was approved, declined, or some problem happened. When the auto shop uses this library, they call the request approval function, they provide it a callback object, and that object says what to do in each of the situations. So yeah, this works, but its structure is kind of awkward. Like instead of getting a result back from the request approval function, as we would for most normal functions, we have to handle each case inside a function. It'd be great if this library were using coroutines instead. So I'm going to show you just how easy it is to adapt this third-party library so that we can use coroutines here instead. Here on the left, I've got a new file where we're going to write our very thin adapter layer. And you can see I've started us off by creating a class that just holds on to the third-party approval system. And just for reference, over here on the right, I've got that third-party code that we had just looked at. Well, we're going to take this request approval function and we're going to wrap it in our adapter. But we're going to make it return a result rather than accept a callback. So let's add a function with the same name as the original. And with the changes I'm making here, you can see that it's got almost the same shape as the original, except that it's a suspending function and we're omitting the callback parameter. And that's because instead of using the callback, our function is just going to return the response from the customer. To create the response objects, we're just going to take the three functions from that callback interface, and we're going to convert them into an enum class instead. Now, if these three functions had parameters, we might want to create a class for each one instead, but since they don't, a single enum class for all three is going to do just fine. So we've changed the shape of this function. We've converted the callback parameter into a simple function result. And this is one of the things that makes coroutines so elegant compared to callback-based code. We can express our code as if it's a regular old function call, but it works concurrently. So with this, we've sketched out what our coroutine-based approval system is going to look like on the surface. And now all we've got to do is just write some implementation that bridges between the callback world and the coroutines world. Now, how are we going to do that? Well, the secret is a function named suspend coroutine. And since we want this code to also handle cancellations, I'm going to use a variant of this function named suspend cancelable coroutine like this. Now, as you can see, these functions both accept a lambda with a continuation parameter. And that parameter is what I'm going to use to glue the callback code to the coroutine. We'll use that in just a moment. But first, we need to call through to the underlying callback-based version of this function. And this way, instead of having to use the callback in our main project code, we're just going to implement it once right here in our adapter. Okay, and then finally, for each function of this callback, we're going to call through to the continuation object. So when the customer approves the estimate, we're going to call a function named resume on that continuation object. And we got to make sure that we import the right one. So I'm going to do that. And we're going to do the same thing for the onDeclined and onError functions. And instead of typing them out, I'm just going to paste them in, just like that. So what's happening here? Well, when we call continuation.resume, we're telling Kotlin to return a value from our function. So when the third-party library calls through to this onApproved function, the result of our request approval function is just going to be this, response.approved. And when it calls on declined, our function returns response.declined. And when it calls on error, our function is going to return response.error. And that's all it takes. There's not much here, but this wraps the callback-based API with a coroutines-based API. So let's see how this cleans up our main project code. So at the top, you can see the original callback-based code, and notice that it requires the approval callback implementation right here. And this version of the request approval function doesn't return a result, it only calls through to the corresponding callback function. But down here, you can see how it looks to use our adapter instead. With this code, we can just launch each request in its own coroutine, and then we call the request approval function from our adapter. And this line looks like a regular old function call, but instead of blocking here, it's going to suspend the coroutine, waiting for a response from the third-party library. And whenever it gets a result, so in other words, whenever the adapter's callback is invoked, it's going to return the value here. So instead of having to process the result here in these functions that are buried in a callback object that's being passed to a function call, we can just receive the response as a function result and process it on subsequent lines, just as if this were a regular non-concurrent function call. So even when you have to work with a callback-based API, you can really smooth over the experience by just wrapping it with a very thin layer that simply maps each callback function to a corresponding result. Hey, if you really want to take your coroutine skills to the next level, I've got a full coroutines course where you can finally nail down the coroutines mental model. I've got a link for that in the description of this video, so check it out. Hey, thanks so much for watching. Remember to like this video, subscribe to the channel, and take some time off this weekend. You deserve it.